Hi everyone, this is Margo. This is Wednesday, July 11th, 2018, and I've been doing some research into ultraviolet radiation and indexes and things like that. This is one area I had not explored on cams. Well, there are a lot of areas I haven't explored on cams, and as I'm exploring these areas and learning about more of the climate and everything that I'm researching, I'm bringing my findings to my audience. And before I begin, I want to thank all of my subscribers and people who are watching these videos who are not subscribers, and the fantastic conversations that are going on in the comment section. I'm so impressed with the people who are listening and watching and commenting, and I have such a knowledgeable group, and I just thank you so much for joining me on this journey and wanting to understand what's going on with our climate and our world, and being on a journey for truth. And I'll get all my announcements and everything out of the way in the beginning. Oh, and also thank everyone from Facebook who happens to be watching this as well. I don't like Facebook. I'll just say it right out. And I'm a very late comer to Facebook, but now I am on Facebook. But I don't do a lot over there except moderate for a Broke Climate Change group, and that keeps me pretty busy, and I get pretty much a lot of the latest information by being a moderator and really interesting articles, and it's really given me an education. So I'd like to thank Roblyn Crawford for allowing me the opportunity to moderate on the Abrupt Climate Change Facebook group, and I really enjoy being there as a moderator. It's not easy work, I'll tell you. It's hard because you just have to make a judgment call sometimes. Anyway, my next announcement is tomorrow. This is a reminder of our live talk show for tomorrow, Campfire Chats with Margo, and we're going to be talking about abrupt climate change, what it means, how it's affecting our lives. We can bring in other topics, and near-term human extinction and things like that. It's going to be at 8 o'clock Eastern Time tomorrow. I made an announcement, a video announcement. It's up on, it's the one right before this video on my YouTube channel, and it's got all of the instructions on how to do it, how to go there and everything. It's going to be on TalkShoe, so if you want to join in on our discussion, you can join in on the phone or on the computer or both. You can't Skype in. I'm using the old version on TalkShoe, but there will be a live chat room, and you'll be able to call in, and we're going to have a discussion, and we can go a couple of hours on this. So I do want people to call in and help me carry the show. So I look forward to meeting anyone who wants to call in, and let's have a discussion. So here is my show on ultraviolet radiation, and we're looking at cams, and I've got quite a few websites that I want to share today. Like I do when I present a topic, I do research about, you know, what it is. Like today we're going to talk about ultraviolet radiation, what it is, the UV index mainly, and how to interpret the UV index and find out what the UV index is for your area of the world, and how you should be protecting yourself, because I was disturbed. When I started looking at this, I was disturbed to really find out how high the UV indexes are around the world. And it's not being reported. The weatherman is not telling us. They're not telling us, and the media is not telling us how awful this is, because they don't want people to get upset. They say, oh, well, put on your sunscreen and put on your hat and put on your sunglasses. But that's not enough, folks. That's not enough. You need to be staying indoors when this UV index is so high. So we're going to go into all of this today. So I'm starting on CAM's Copernicus Atmosphere Monitoring Service that you're familiar with now if you've been watching any of my videos. And the filter that I've selected is down at the bottom, UV index forecasts. And I'll leave a link below to all of the websites that I'm using. And when you look at this, and their data is up to date, and they're on UTC time. So if you're west of the universal time timeline, then this data is in for today already. If you're east of it, this data, you're already into the 12th. So this data was for the day before. But I've got another website where you can see what the data is for you right here, right now. So this is their data goes back 5 days and it goes back to Saturday. And so if you want to see what your UV index was on any of these days, going back 5 days, you can click on the data there. But I've got the data, the most recent data clicked. And when you come to this website, it'll default to total sky UV index, and they account for clouds and weather and things like that have been reported in, because that affects the amount of UV that comes down to the surface. But I've chosen this one, the clear sky UV index, because I live in northern Nevada and it's normally clear skies here. And so your UV index is going to be higher if there's no clouds and no weather, and it's also going to be higher in the summertime and with the heat and the tilt of the earth. And it's a science to figure out the UV index. And so this is why we rely on the scientists to get the data, and then we can look at the data. And so just looking at, I've got the global view here, and first of all, it's in a circle because the UV ultraviolet radiation comes down from the sun. And so if it's nighttime, like where it's daytime over here, it's going to be nighttime over on this other side of the world. And so it's only going to be showing up where the sun's shining down. But as we do the movie, you're going to see this move across the screen as the sun goes from east to west across the globe. And you'll see this UV circle move across the globe. But first of all, let's understand what we're looking at. And this is the UV index. Now this is the universal, there is a universal UV index, and I didn't know this before I started all this research. So this is worldwide. So this is the same index for everybody worldwide. And so the lowest is this dark green, which is 1. And then you've got this kind of olive green, which is 2 right here, and then you go into yellow, which is 3. And from what I read, they say that once it reaches 3 or higher, you need sun protection if you're going to be outside for any length of time. And so then it starts going into the into the darker range, into the golds, and into the dark, then reddish gold, and then the red is at 8. So when you see that red, that's 8, and so you're needing definite sun protection. And then it's this maroon color is 9, purple is 10, then the blue purple, I don't know what color we want to call this, blue purple, is 11, and that's this color here. It's very wide. And then you start really getting into the blues, and that's 13, and we've got a big patch of 13 in the middle. And then you're going to see it go up even higher. But I'm going to show you websites that say once it gets to 10 or higher, then that's very damaging, and you just don't want to be out. Or if you're going to be out, I recommend you cover up and wear long sleeves and a hat that covers your whole face, and sunglasses that's blocking out ultraviolet radiation, and just don't be out, because this is very, very damaging, very damaging. So we're going to spend some time on cams now and after I show you all of these other websites. And another thing, you can only really see the forecast from this charts view. This is from the CAMS charts view, not from the plots view, because they've stopped updating this information in the plots view as of May the 8th. And I thought I was going to do this in plots when I loaded in, when I went to my plots view, loaded in UV index, and it does show up here as global solar UV index forecast. But when you click on that, and this is a much bigger picture, and I wanted to do this one because I like the plots view for methane and sulfur dioxide and ozone and things like that, and carbon dioxide. But when you go to that, it says, warning, these plots are not up to date anymore. Please use CAM's website for up-to-date images. And so you can go back, and if you want to do some research and go back and have the bigger picture, you can go back a long time. You can go back for years on this. You can go back a long time, but they're not using this plots view, not updating it anymore. So then when you click on CAM's website, then it takes you to the charts page. And these are the things that you can see in charts. And I use charts too. I think charts is good if you want to zoom in to a specific area. You can use the charts view. So that's why I'm going. Then when you click on it, like if you click on this, like where I got to, it's going to default, like I said. You see how it looks different? It defaults to the total sky. So then you have to change the setting. Okay, so that's how I got to where I'm at now. But I'm just going to leave the link below. And I may use the plots view to look at some ozone, because ozone, if you want to go back and watch my 3 videos on ozone, because with the thinning ozone, that's going to give us higher UV, and you're going to see a correlation. I'll just go over to ozone right now. Plots. Uh-oh. Now this is, it defaults to total column, which is what I want, because we want to see the total column, because this ozone, the total column of the ozone is what blocks out the UV radiation. And so you can see a total correlation here with the thinning ozone, with this blue, where it's the and it's thinnest from like the blue up into the yellow, yellow, like this darker yellow is at 325 DU, but you can see this, like where it's really thin, and you want it really higher than 300. They say 300 is average, but that's averaged out between the lower and the higher. So the higher you go in the DU, that's the more protection in the total column that you have. So what you're going to see is a total correlation of the thin ozone over here, over the whole planet, and the ultraviolet index. So I'm going to run this movie. Now this is going to be a forecast starting from today, July 11th. This is UTC time, and every one of these little clicks is every 3 hours. So what you can do is you can go to this website and actually see like what the UV is on your area. You can also change the area. While this movie's loading, I'll show you. You can change the area here. Like if you want to go just to North America, you can click there. Or if you want to go to Europe, you can click there. You can click pretty much all around the globe, and it'll zoom in to your specific area for the UV. Okay? But we're just going to stay on global right now. And this movie is loading, and here it goes. And now it's forecasting for the next 5 days the UV radiation according to the data that's been put into the system. And you can see that especially over the east tropical area of the world, it's very high. It's going up into the 13 range, which is the danger zone, very much danger zone. And you've got certain times of the day where it's the highest, like from about 11 in the morning till about 2 in the afternoon. That's when it's the highest. But you want to look at whether you're on daylight savings time. It's a whole thing. So this is what we're looking at. And so what you're seeing, I'm going to stop the movie now, and now I'm going to go back to I'm going to go back. See, you can stop it at the 3-hour marker and see like where the sun is over your area. It's where it's going to be the highest, and then it's going to start going down. So if you're going to be outside, you want to be out in the morning before it really starts getting up into the red zone or the orange zone, or late in the afternoon it's going to be going down into the greens, the yellows and the greens. So there are more safe times in the day for you to be outside, but this is disturbing because the weatherman doesn't tell you that the UV is going to be 13 in your area. So we're on our own. We're literally on our own to figure this stuff out because they don't want people to be upset. They don't want people to stay inside. They want people to go out and go to amusements and go do their vacations. And if you're vacationing over here in the Bahamas or any I'm sorry, I got mixed up. Bahamas are here, but they're going to be in a danger zone. You got the Philippines and Indonesia and New Guinea and these South Pacific islands where people like to go on vacation. You're going to be in the danger zone. So if you're outside on the beach enjoying the sun, you're soaking up this dangerous UV radiation that is going to damage you, and the damage is going to happen later. The damage is not going to happen immediately on a lot of stuff, but the damage is going to be happening later. So then it goes across. You can see here it is coming across, going to the west, hitting Africa and Saudi Arabia and these areas. You can see parts of India are in the danger zone. And this is strictly sun, strictly from the sunlight. Here it is over Europe and the northern areas. You can see like Norway, since they're farther north, they're not as much in the danger zone for UV, England and such. So we're looking at the mid-latitude, really the mid-latitudes, which includes most of the a lot of the northern hemisphere. And here it is coming across the Atlantic Ocean, and so the danger zone is going to be the Bahamas, and going across, and when it comes across, it's going to be Mexico, Central America, northern South America, and also the United States is going to be in the danger zone, is what you're seeing, just depending on where you are and the time of day. So it's a wide area that's really covered. So I would say this purple-ish is 11, and then you have patches where it goes up into the 13 here. And then as it moves across, of course, Hawaii is going to be, here's Hawaii, and it's up in the danger zone. But let's go back. You see, this covers this whole area from northern South America up into the United States, all of the United States as it goes across, except for the very northern. And even the very northern, you're in the red zone. You're at 8. So that's what you've got going on. I'm going to pause and get a drink of water here. Okay, so now let's look at UV radiation and how bad it is, what it is, and how bad it is. Now this is just some very basic information from the CAM's website. This is explaining the UV index, and because I didn't know, and I just followed all of these links to figure out what it meant. And they get their information from SunSmart, which is an Australian website that has a lot of really good information. We're going to go there too. And they have a phone app that you can download that can show you current readings wherever they are in Australia. So if you're in Australia and you want the UV readings there, and actually, if we go back on the movie, Australia gets high UV readings in the summertime. Now they're in the wintertime, so that's why their UV readings are lower than they would be in the summertime, because the Earth is tilted. That southern part of the Earth is tilted away from the sun, so they're not as high in UV at this point in time because they're in the winter. But they're still getting pretty high readings in the northern part. You can still see it in the red, which is 8. So those of you in Australia might want to go ahead and download this app as well. So other parts of the world are just really up on all of this stuff. And, I can see how those of us in the Western Hemisphere, US and Canada, I mean, we're kind of out of the loop here. So, this is, and CAMS is from the European Union, and a lot of the websites that I use are, from different parts of the world, European and Australian. I mean, they're really, really up on all this stuff. So this is great. So you can download the app and you can be alerted when the UV rays are going to be going up in your area and everything. Here's an overview. Ultraviolet radiation, or UV, from the sun is both the major cause of skin cancer, and it's also the best natural source of vitamin D. Cancer Council Victoria in Australia established the Sun Smart program in the 1980s in response to the high incidence of skin cancer. Research has shown people continued to rely on temperature or sunny conditions to make decisions about when to protect their skin. The UV index was not well understood or often misinterpreted. The SunSmart website provides the public with tips and information and offers a downloadable phone app for Android and Apple devices called SunSmart. The SunSmart app and widget were first developed in 2010 with the aim of translating the UV index into an easy, useful tool that would help Australians make informed decisions about sun protection. SunSmart makes it easy for users to maintain safe levels of UV exposure by checking the UV index at their location at any time. That helps them reduce their risk of skin cancer and still enjoy the health benefits of sunshine. The app makes use of data on UV radiation levels across Australia provided by the European Centre for Medium Range Weather Forecasts, Copernicus Atmospheric Monitoring Service via Australia's Bureau of Meteorology. So it's a coordination of these groups. Now here's some background. Despite being one of the most preventable cancers, 2 of 3 Australians will be diagnosed with skin cancer by the age of 70. Not only Australians, but people in other places of the world too. The SunSmart campaign encourages people to be SunSmart and slip on a shirt, slop on sunscreen, and slap on a hat to mitigate their UV exposure risk. SunSmart focuses on raising awareness in schools, workplaces, local government, sports, and community organizations, and with health professionals, etc. And their solution is to download this app that gives them a 7-day forecast and the results and everything. And their conclusion is UV damage is the major cause of skin cancer but it can't be detected by any of our senses until the damage has already been done. With the SunSmart app, we can use UV data to increase people's awareness of the levels and so forth. But the UV radiation also damages our eyes, and it unwinds the DNA on our skin and things like that. So then I went to the SunSmart website, which is here, and I'm going to leave links to below. And this is out of Australia. This is the one that Cams was talking about. This is a wealth of information for anybody, not just from Australia. And if you go to what is UV, this gives you an overview about protection times, UV index. I didn't know anything about the UV index until I came here. And the World Health Organization, you can go to that website, and it goes about UV index, measures UV levels on a scale from 0, which is low, to 11 plus, which is extreme. So what we saw on cams where it was 11, that's considered extreme. Sun protection is recommended when UV levels are 3 or higher. They consider 3 moderate. Well, when we look at cams, it's at 3 almost all day or above, almost all day. When you see this march across your location, you can see that it's high. I mean, it's above 3 most of the time. The UV level is affected by a number of factors, including the time of day, time of year, cloud cover, altitude, and if you're at a higher altitude, you're going to get more radiation too. How close you are to the equator, scattering and reflection. The sun protection times show when UV levels are forecast to be 3 or higher. You can find the sun protection times at your location on the free smartphone app, SunSmart app, or at the Bureau of Meteorology website. Now this is Australia, so the health effects of too much UV radiation can cause skin and eye damage, sunburn, tanning, and skin cancer. Some UV exposure is recommended for vitamin D. We do need some sun because our body makes vitamin D from the sun being absorbed through the skin. So we do need some sun. So you want to go out and get sunlight before it gets into the really the dangerous period, like early in the morning or late in the afternoon is the best if you want to be out enough. But you don't need a lot. You know, 15 minutes is really 15-20 minutes. I don't even get that much, and I take vitamin D supplement, and my vitamin D range is fine. I just got tested, did a blood test and stuff, and my vitamin D is fine in my blood level. So you can take supplements too. You don't have to get it from the sun, but it's good to get some sun a little bit. They recommend every day if you can. Anyway, sunburn is a UV radiation burn to the skin. In Victoria's summer months, skin can burn in as little as 11 minutes and can take days or weeks to heal. Mild sunburn can be treated at home, but you should see a doctor immediately for severe and/or blistered burns. Find out more about sunburn treatment at Better Health channel. Now, sunburns are serious, and when I was a teenager, You know, I would go to the pool and lay out because I was wanting to tan. I'm very fair skinned. I would never tan. I would blister and burn. And that's the kind of thing that will set you up for skin cancer later on. And I did have, in my 40s, I was diagnosed with, the doctor said it was melanoma. I'm thinking it was just the very beginnings of it, and they took it off, and I haven't had any recurrence. But you had to be very careful, and it was on my ankle. It was on my ankle, underneath where I wear my socks. So that had to have been from damage from when I got sunburned in my teens. Okay, while the signs of a sunburn fade with time, the damage can't be undone and adds to your lifetime tally of UV damage, which increases your risk of skin cancer. Sunburn prevention is best. Always check the sun protection times on the free SunSmart app and use a combination of sun protection measures when required. Eye damage. UV damage can cause photoconjunctivitis, which is also known as snow blindness or welder's flash, photokeratitis, macular degeneration, cataracts, pterygiums, and skin cancer of the conjunctiva and skin surrounding the eye. The conjunctiva is the inner lid. Like when you pull down your eyelid, it's the inside of your eyelid. So this is very, very, very serious. Premature aging. Up to 80% of fine lines and wrinkles are the result of UV damage. UV also causes skin sagging, blotchiness, and roughness. Photosensitivity is an abnormally high sensitivity of the skin or eyes to UV radiation. This means the skin can burn more easily, increasing your risk of skin cancer. Photosensitivity is caused by ingesting, inhaling, or coming into skin contact with photosensitizers, substances that cause photosensitivity. Photosensitizers include industrial chemicals, drugs, plants, and some essential oils and fragrances. Some medications can cause photosensitivity. Check with your doctor or pharmacist as alternate medication may be available. So you may be on some kind of medication even, or an herb that can be make you more sensitive to the sun and you know, make this more harmful. Information on substances which can cause photosensitivity can be found in the guidance note for protection of workers from ultraviolet radiation and sunlight from the Safe Work Australia with that link. So this is all right here on this one page on the SunSmart website. So I recommend everybody go read about all of this and check out more information on their website, because this is good. This is good. Now we're going to move on. Now we're going to talk about the ultraviolet index. Now this is from Wikipedia. The ultraviolet index, or UV index, is an international standard measurement of the strength of sunburn producing ultraviolet radiation at a particular place and time. The scale was developed by Canadian scientists in 1992, then adopted and standardized by the UN's World Health Organization and World Meteorological Organization in 1994. It is primarily used in daily forecasts aimed at the general public, and is increasingly available as an hourly forecast as well. It was designed as an open-ended linear scale directly proportional to the intensity of UV radiation that causes sunburn on human skin. For example, if a light-skinned individual without sunscreen begins to sunburn in 30 minutes at UV index 6, then that individual should expect to sunburn in about 15 minutes at UV index 12, twice the UV, twice as fast. The purpose of the UV index is to help people effectively protect themselves from UV radiation, which has health benefits in moderation, but in excess causes sunburn, skin aging, DNA damage, skin cancer, immunosuppression, and eye damage such as cataracts and other eye damage, which is what we saw as well. Public health organizations recommend that people protect themselves, for example, by applying sunscreen to the skin and wearing a hat and sunglasses. But you need sunglasses that are going to be blocking out as much as the UV rays as you can. But some of these damaging UV rays are coming through that can't be blocked out, like UVC. It's coming through too. So anyway, this is if the UV index is 3 or higher. I say if you go outside, you need to protect yourself. Now, here's a description, and here's the difference between clear sky and, if you've got clouds and stuff, and it says it's going to be higher with areas with now this is average ozone layer depletion, but we've got you can see that it's the ozone layer is depleting more and more and more, and so I don't even know how accurate these UV indexes are if they take into the account the thinning ozone. I really don't know. So you can go to this page and read. Now this is a good chart. This is the World Health Organization UV index. This is an example for New York City, assuming clear sky, thinned ozone, horizontal surface. And this is from their Fast RT UV calculator. And so this starts in the daytime, like at 0 before sunrise, and here's 8 a.m. and then here it's starting to go up, go up, go up. And so you can see that by about 9:30 in the morning, it's already at 6, UV index of 6. And this is depending on the month, so and time of year, okay? So if it's January, it's going to be low, but if we're in May and June and July and August, it's going to be much higher, and it only goes up through June. Here, oh well, okay, here's August, July and August, September, because they say June and July are going to be your highest, because then the Earth starts tilting away from the northern part of the Earth starts tilting away from the sun, moving back down. So you can use this as a guide, as a scale, but you can see that once you get up into even May, June, July, and August, those are the most dangerous months to be outside for any length of time, and especially in the middle of the day. But June, July, and August are the highest, and it goes up to 10. And we saw from the CAMS website that it goes above 10. And if you're south of New York City, then your UV is going to be higher from what we saw on this CAMS thing. Okay? So you take all of these together, and figure out what time you're going to be outside, and gauge how you're going to protect yourself. I wear long sleeves when I go out. If I'm going to be out for any length of time, I put on a long sleeve shirt over everything else I'm wearing. I have a hat, I have sunglasses, I put on tennis shoes with socks because I don't want my feet exposed. I do wear shorts, but it's just a short amount of time. I don't stay out in the sun. I'm just like going to my car and back and forth. And then when I'm in my car, it's usually shaded in there. So you can read these. And okay, here's why it's so dangerous. You can't detect when it's dangerous physically, because okay. 1 hour of exposure at index 5 is approximately equivalent to half an hour at index 10. Although other factors like the body's ability to repair damage over a given time period could detract from the validity of this assumption, you also have to go by your skin type. And if you're fair, like I am, you're going to be affected sooner. So this is serious stuff. So anyway, I can't read all these websites to you. This is for you to look at. Here's another website. This is the EPA, from Environmental Protection Agency from the United States, government site, UV Index, a guide to the UV index. What is UV? The UV index was changing. And even though they switched over to a new UV index, the readings are the levels are still the same, but they changed what used to be high. Prior to May 2004, high was 7 to 9, but now 7 to 9 is now considered very high. So when it was minimal is now considered low, 1 to 2. The old low, 3 to 4, is now moderate, 3 to 5. High, the old moderate, 5 to 6, is now high is 6 to 7. Very high is 8 to 10. Extreme is 11 and plus. And so you can see over here on cams, a lot of the area is extreme, 11 and plus. Here's 11. That blue purple is 11. So this is a good website. They talk all about when to take precaution, this and that, different times of day, latitudes, cloud cover, ozone, all that stuff. And we've talked about ozone and how the thinning ozone allows more UV radiation to come through, etc. Skin cancer, eye damage. It can suppress the immune system, can make the body more vulnerable to infections and cancers regardless of an individual's skin type or susceptibility to burns. Plus, they don't talk about this. Nobody talks about this. But what about the nuclear radiation coming over from Fukushima, and that's already in the atmosphere? We're adding that to the mix too, into this UV radiation, and so I'm thinking that compounds everything. Here's the different kinds of skin cancer that can be developed. Basal carcinomas are tumors that usually appear as small fleshy bumps or nodules. Squamous cell carcinomas appear as nodules or as red scaly patches. Melanomas may appear without warning as a dark mole or other dark spot on the skin. Melanoma causes more than 75% of skin cancer deaths. There are more than 50,000 new cases of melanoma per year. 1 in 4 persons who develop melanoma are under 40. So, and when I had that diagnosis and they took it off, I didn't have to go into the hospital. It was an outpatient procedure in the office. Well, I did have to go and get checked out for everything else too, but they did follow up for 5 years. 5 years, and they say, you know, if you remain free 5 years, then you're good. So I did follow up for 5 years, every 6 months. Okay, now this last website I'm going to go over with everyone is the ESA TEMIS tropospheric data. This is a European website. They show, this is a fantastic website. They show forecasts and archives for UV index all around the world. And here's their home, this is their home page. And you can just click on your area. You can go to Total World. And you can see, get your own location. This is a phenomenal website. They use the same UV index. The coloring is a little different here, but it's the same UV index. So if you go on Total World, this is what it looks like. So it's, you can see like July 11th. This is for your location when the sun comes across, what it's going to be. And so if you're in this red zone over here in the United States, you're going to be getting about 12 to 13 UV over here from, and it goes from about Colorado over almost to California, and then that wide patch down, that's probably part of Texas, probably all of New Mexico and Arizona, and then down into Mexico, and down all the way down into Central America and northern South America, and see parts of Europe get that red, and see, now look at this over Russia. This is parts of Russia and northern, not Russia, maybe parts of Russia, southern Russia, and China and Asia and India. Their index is, it's literally off the chart. See that white? That's 18. So over here, I don't know what area that is. I'd have to go to my world map to see, but that's white. That is 18. So 16 is the purple. So that's 18. So if we go, I've got my world map up, we can check out, that's Asia. So that's about, well, they're trying to put an ad up. That's over this area, like Mongolia. I'm thinking that's, you know, Tibet, where they have the high mountains, where it's such high altitude. That's where that's probably happening. That's where the ozone can be very thin there, but it's a very high altitude. That's disturbing. And then you can explore this website, but what I want to show you is really cool about this website. You can see your UV index for your individual location. You can either go by list of names. This is worldwide, just famous places worldwide. Like here's Hawaii. Let's see the UV index in Hawaii today. Hawaii is at 11.9 UV index, so they're in the danger zone, and their total column ozone is 290 DU. We saw that. We saw that, so when you go over here to cams, and we got to move the movie forward a little bit to get over to Hawaii. Actually, so this is, so you know, cams is an estimation. This is actually more accurate, 11.9. So that was, actually cams was 11, okay, so that's 11 to 13 that Hawaii's going to be in. Let's see if we click that one. Okay, there's Hawaii. So that's probably pretty accurate, but if you want the exact numbers, you can come over to this website, the TEMIS website. And then they do a 5-day forecast. We can see on July 12th, Hawaii is going to be 11.8. And their, for UV, and their ozone total column is 293.5 DU. So that's very thin. On July 13th, their UV index is going up to 12.9. And total column ozone is going down to 275 DU. I wonder if this is because of all that sulfur dioxide from the volcanoes that have been erupting that's just destroying the ozone layer there. On July the 14th, the UV index for Hawaii is going to be 12.2. Total ozone 287.1. July 15th, UV index is 11.9. Total column ozone is 292.2. And July 16th, 12.9 UV index. And ozone total column is 275.6. That's for Hawaii. This is for clear sky. So you can click on any of these. Or here's another way. They've got a map, and anywhere these red dots are, you can click, like Boulder, Colorado. Let's see the UV index for Boulder, Colorado today. They're very high altitude. They're higher than Denver, and Denver is called the Mile High City because it's at a mile high altitude above sea level. So for Boulder today, your UV index is 11.5. And your total column ozone is 281.5. So you're in the danger zone, Boulder. You can also, okay, let's see, just for the heck of it, let's see, Chengdu. Let's see the total column, or index. Oh my God. Look at Chengdu. I'm assuming this is in China. Chengdu, your UV index today is 13.1. And your total column ozone is 271.7. Chengdu, you're going to be in the danger zone for the next 5 days. 13.1, 13, 12.8, 13.1, 13.5 on July 15th, and 12.4 on July 16th. Chengdu, I'm sorry. Let's see for my Australian viewers. Let's check out Darwin, Australia. This is right on the northern tippy tip. Darwin, your UV index for today is 8.2. Now that's during the hottest part of the day, like 11 in the morning till around 2 in the afternoon. So your UV index is going to be lower in the, earlier in the morning and later in the afternoon. So you're not as bad off as the rest of us. Your total column ozone is 255.2 DU. That's thin. That's very low, Darwin. Let's check out, just for the heck of it, Lima, Peru. I mean, I could spend all day doing this. Lima, Peru, your UV index is 9.1. You're in the very high zone. Your total column ozone is 255.8. You're very thin on ozone, Lima, Peru. Now let's check it out. Where's this? Mexico. This is probably Mexico City. Okay, you've got the highest so far, Mexico. Today your UV index is 14.2. And your total, well, you're not as high as Chengdu. Chengdu was higher at well, no, wherever that was, at 16. But Mexico, you're at 14.2, and your total column ozone is 276.4. Okay, everybody, you get the idea. Let's see what it is in Bermuda. This is a vacation spot for a lot of people. Bermuda, your UV index today is 10.1. Your total column ozone is 316.1. So, people out there enjoying the sun, you're putting yourself up for lots of problems. Let's check out Havana. Havana, your UV index is 11.1. Your total column ozone is 306.2. So, you get the idea, everybody. One more thing I'm going to show you on this website. You can also put in your longitude and latitude and get your specific ozone and UV index for the day. So I've got this website up. Let's say you don't know your longitude and latitude coordinates. Let's say you live in, just for the heck of it, let's type in What do we want? Where do we want to find? Where do we want to find Dubai? Let's say Dubai. Okay. And Dubai is in the Middle East, and it's part of Saudi. I think it's part of Saudi Arabia. Your latitude is this 25. And we're going to copy and paste. Copy your latitude and put that in there. Your longitude is 55.27. I'm going to paste that in there. And we're going to get your forecast, Dubai. Well, Dubai, your UV index is bad. Your UV index is 12.4. And on the 13th, it's going to be 14. Your total column ozone is 285.1 today. So that's how that works. So I will leave links to everything below. So you understand a little bit better now about what's going on and about the seriousness of this situation and how basically we're being cooked alive, folks. We are being baked. If you wonder why you're sick, if you wonder why you can't get well, if you wonder why your immune system is down, if you wonder why you've got dry eye syndrome, you're getting cataracts earlier, you're getting skin cancers, you're getting this, you're getting that. This is like the last nail in the coffin. Well, not the last, but the next one in my discoveries of what I'm bringing to you. So here you go. Time is short, folks. Time is short. It's time to get your spiritual houses in order. I hope to talk to whoever joins me tomorrow on Campfire Chats with Margo on my Talk Shoe radio show at 8 p.m. Eastern Time. Until next time, my website is margoshealingcorner.com. I'm a hypnotist, holistic life coach, empathic spiritual healer. I'm focusing my full attention on bringing you climate forecasts and helping people to come to grips with what we're having to deal with. This is the end, I believe. The end of, it's at least the end of life as we know it. I love every one of you. I love you all, you guys. God bless every one of you. Until next time, go in peace. Goodbye.